Question 16 says, in a resonance tube experiment, when the tube is filled with water up to a height of 17 centimeter from bottom, it resonates with a given tuning fork. When the water level is raised, the next resonance with the same tuning fork occurs at a height of 24.5 centimeter. If the velocity of sound in air is 330 meter per second, the tuning fork frequency is, and the four options are given. Well, clearly the question is from the topic waves, that too sound waves, and specifically in sound waves it is about the resonance tube. Let us draw a diagram to describe the situation. So, in the first case, the height of water level is 17 centimeter from the bottom. So, let us draw that. Say we have something like this is the tube and this is the level of water. This is given as 17 centimeter, right? And we have a tuning fork, vibrating. The column of air is in resonance with the tuning fork. Now, in this particular case, if we look at this length L1, okay, we do not know the value of L1, that is not given, but we can write here that L1 must be an odd multiple of lambda by 4, right, where lambda is the wavelength of the sound. So, L1 is equal to odd multiple of lambda by 4, we can write it as 2n minus 1 times lambda by 4, where n is an integer. And in the next case, as the level of water is increased, the height of water becomes 24.5 centimeter. So, in that case, once the level of water has increased, the new height of the air column now becomes less than L1. In fact, because this has gone up by 7.5 centimeter, because the height has become 24.5. So, that means this difference is 7.5 centimeter, and it shows that L2, if I call this length of air column as L2, then the value of L2 is in fact equal to L1 minus 7.5 centimeter. Now, what should be the value of L2? So, it means we can equate this to as 2 into n minus 1 minus 1 into lambda by 4. So, we have these two equations, and if we substitute, we get the value of lambda. The value of lambda comes out as 15 centimeter by solving it. So, if once we have the value of lambda as 15 centimeter, the frequency we can get easily by dividing the speed, which is 330 meter per second, divided by the wavelength lambda, which is 15 centimeter. So, now we need to multiply it by 100, and this is the frequency in hertz. Well, if we solve it, this comes out as 2200 hertz. So, let us now go back and check the options. The very first option is 2200 hertz. So, that means option 1 is correct. Let us go now to question number 17. Question 17 says a galvanometer of resistance capital G is converted into a voltmeter of range 0 to 1 volt by connecting a resistance R1 in series with it. The additional resistance that should be connected in series with R1 to increase the range of the voltmeter to 0 to 2 volt will be. A pretty simple question based on current electricity. It is about conversion of a moving coil galvanometer into a voltmeter. Now, let us assume that the full scale deflection current is Ig, and the equation that we will get is Ig multiplied by capital G plus R1 is equal to 1 volt. Let us write that. We have Ig, the full scale deflection current in the moving coil galvanometer, multiplied by capital G plus R1. This is coming out as 1 volt according to the question, and when we are connecting R2 also in series with it, the range goes up to 2 volt. That means the second equation is Ig into G plus R1 plus R2 is equal to 2 volt. Now from these two equations, it is very clear that the value of R2 that needs to be connected in series to increase the range to 2 volt is equal to in fact G plus R1, and that means option 3 is correct for question 17. Let us go to question number 18 now. Question 18 says a balloon is moving up in air vertically above a point A on the ground. When it is at a height h1, a girl standing at a distance d, point B from A, see figure, sees it at an angle of 45 degree with respect to the vertical. When the balloon climbs up a further height h2, it is seen at an angle of 60 degree with respect to the vertical if the girl moves further by a distance 2.464 d, that is point C in the figure. Then height h2 is given, in fact h2 is, and it is given that tan 30 degree is 0.5774, that is given to us. This is the diagram that has been given. Now from this diagram we can straightway point out that this angle is 45 degree, there should be no doubt. So this was the initial position of the girl, and at that time this was the position of the balloon. When the balloon has gone up to this point, the girl has moved up to this point, this angle has become 60 degree. So clearly this angle would be 30 degree. Now as far as the topic is concerned, we can put it under the category of motion in a straight line. The balloon is moving in a straight line. Now from this smaller right angle triangle, since the angle is 45 degree, we can say that h1 is equal to d, pretty straightforward, h1 is d. And if you look at the larger triangle, the larger right angle triangle, which is like this, so we can put tan 30 degree as it is a perpendicular by base. So h1 has become d, h2 plus d divided by, so we have it h2 plus d divided by d plus 2.464 d, that means 3.464 d. So let us put it as 3.464 d. The value of tan 30 degree is given to us. Even if it was not given, it would not have been a matter of concern at all, because it is a pretty straightforward standard angle. Tan 30 degree we know is 1 by root 3. So we put it as either 1 by root 3 or 0.5774 and solve for h2. The value of h2 after solving this comes out as h2 is equal to d. So if you look at the options, the first option matches with our solution. This question is done. It is time now for us to go to question number 19.